What if paradise didn't die? It simply burned. There's a world in our solar system so bright it outshines the stars, so beautiful it was once named after a goddess of love. But beneath that radiance lies a graveyard, a planet that once may have looked like Earth and then became hell. Please like and subscribe because this journey will change how you see our place in the universe. Prepare yourselves. We begin. Venus, second from the Sun, twin to Earth in size, mass, and structure, was once called our sister planet. And yet, the two sisters have lived opposite lives. Earth evolved into a cradle of forests, oceans, and consciousness. Venus became a furnace of death. At 880 degrees Fahrenheit, its surface glows red hot, hot enough to melt lead, to erase anything resembling biology. The atmospheric pressure is crushing 92 times that of Earth's, like being buried beneath an ocean 3,000 feet deep. And the air? Poison, carbon dioxide, sulfuric acid, the stench of rotting eggs. Even the machines we send, metal titans built by our finest minds, survive only minutes before collapsing, crushed and cooked. And yet, despite this hellscape, something impossible was found in the sky. A whisper, a signature, a molecule not made by any known geological or chemical process. Phosphine, a simple compound, one phosphorus atom bound to 3 hydrogens. Here on Earth, we only know it from 2 sources: humans who manufacture it for war and agriculture, life specifically anaerobic bacteria that thrive in the shadows of swamps and landfills, where oxygen cannot reach. So when we found phosphine drifting in the clouds of Venus, we didn't just find a gas. We found a question so massive it shakes the foundations of biology, chemistry, and everything we thought we knew about life in the cosmos. Is something alive in the sky of a dying world? The search began with radio telescopes. The James Clerk Maxwell Telescope in Hawaii and ALMA in Chile trained their eyes on Venus and detected phosphine where it had no right to be. There's no known way for it to form in such extreme conditions, not without life. And yet there it was, a ghost molecule, out of place and screaming for attention. But how? How could anything endure such violence? To answer that, we must look back, not millions of years, but billions. Long ago, Venus may have been habitable. It had water oceans, possibly even continents. The Sun, younger and dimmer, didn't bake it mercilessly. For 2 to 3 billion years, Venus may have been a kind of tropical Eden, a world with shallow seas, temperate skies, and just enough time for life to spark. But then, something happened. 700 million years ago, Venus died, violently, catastrophically. A runaway greenhouse event, possibly triggered by volcanic eruptions on a planetary scale, spewed carbon dioxide from its crust, thickened the atmosphere, and trapped heat like a sealed oven. Temperatures soared. Oceans boiled into steam, land melted into lava, and the sky turned to sulfur. The Earth could have followed, maybe still could. But here's the haunting part. If life had already begun, it wouldn't just vanish. Life doesn't give up that easily. It hides, it adapts, it evolves. And where could it go on Venus? To the clouds? About 30 miles above Venus's surface, there exists a narrow band of atmosphere with temperatures and pressures similar to Earth. It's not perfect, it's still toxic, but it's possible. Here, in the twilight zone between death and light, the conditions are survivable. Sunlight? Check. Organic molecules? Check. Water vapor? Check. The building blocks are there. The question is, did they ever build something? Some scientists say, hold on, it's too soon. Maybe the signal is wrong. Maybe it's a fluke. Others argue, if it's not life, then it's something we don't yet understand. Some new chemistry, some rule of physics we've missed. Either way, Venus refuses to be silent. She doesn't just orbit the Sunday. She warns us. She teaches us. She haunts us. Because Venus is more than just a planet. She's a prophecy. She shows us what happens when a world teeters too far into imbalance. She's Earth's mirror, cracked and melting, whispering, "This is what you could become." And if there is life up there, in those clouds, life that survived apocalypse, then it is not just alien, it is ancient, it is adapted, and it is terrifyingly resilient. And that changes everything. If life can exist there, in clouds of sulfuric acid, above oceans of fire, then the universe is far more alive than we dared imagine. It means the boundaries we draw between possible and impossible are no longer relevant. It means Earth may not be unique, and we may not be alone, and maybe, just maybe, life doesn't need paradise. Maybe it just needs time. So, we look again, and we send missions again. NASA, ESA, Rocket Lab, they're all preparing. In the coming years, probes will pierce those clouds, searching not just for phosphine, but for what comes next, for answers to questions as old as wonder itself. Are we the first spark in the dark? Or merely one of many, caught between two burning worlds? Venus keeps her secrets for now, but not forever. What if the most important message we ever sent was to someone we'll never meet? Before we walked on the moon, before we built machines that danced on Mars, we looked out into the abyss and did something unthinkable. We launched a spacecraft with no intention of it ever coming home. No rescue mission, no final destination. Only one directive: go as far as possible and listen. It was 1977. The Cold War raged. Earth was fractured. But in the quiet corners of NASA, something more profound was taking shape. Voyager, two robotic emissaries, built not just to study our solar system, but to leave it, to escape the sun's gravitational embrace and carry humanity's story across the stars. But Voyager wasn't just a probe, it was a bottle, flung into a cosmic ocean, carrying a golden record etched with the music of Earth, from Beethoven to Chuck Berry, from Senegalese percussion to the sound of a heartbeat. On that record, engraved in a whisper of metal, "Hello from the children of planet Earth. Can you feel the absurdity? The beauty?" We had no idea if anything would ever find it. We just believed the attempt mattered, because Voyager wasn't for them, it was for us. It was our way of saying, we were here, we reached for something bigger, and we cared enough to send love into the unknown. Two Voyagers, launched 16 days apart. Voyager 2 first, then Voyager 1, destined to overtake its twin, thanks to a shorter trajectory. Their mission? Exploit a once-in-175 years planetary alignment. Jupiter, Saturn, Uranus, Neptune, a celestial slingshot across the outer worlds. The timing had to be perfect, the mathematics brutal, the ambition cosmic, and it worked. Voyager rode the gravity of giants, gaining speed with each planetary encounter like a stone skipping across the orbits of the gods. But this wasn't just about speed, it was about revelation, because what Voyager saw changed how we see everything. Jupiter was first, a swirling titan of gas, 318 times the mass of Earth. We had seen it through telescopes for centuries, but never like this. Voyager flew close, so close, and captured storms the size of continents. Lightning bolts 1,000 times more powerful than Earth's. And Io, one of Jupiter's moons, spewing lava into space like a volcanic siren. Io was alive, not in the way we once imagined life, but in the way planets dream, in fire, in chaos, in motion. And then Saturn, the ringed wonder, the jewel of our cosmic crown. Through Voyager's eyes, we didn't just see Saturn's rings, we understood them. Not static, not solid, but a swirling dance of ice, dust, and gravity, a symphony of frozen shards reflecting the light of a distant sun. Voyager discovered moons we'd never known: Prometheus, Pandora, Atlas, each one a frozen whisper, orbiting like sacred beads around a god. And then came Titan, Saturn's largest moon. Thick atmosphere, strange chemistry, a hint, just a whisper, that beneath its haze there might be oceans, and maybe, just maybe, something else. But Voyager wasn't done. The mission was meant to last 5 years. It would go for decades. NASA extended the journey, because how do you stop a story this grand once it begins? Voyager 2 pressed on, past Saturn, into the unknown. Uranus, Neptune, the ice giants, we had only guessed what lay there, Voyager told us. Uranus spun sideways, a planet knocked on its side by some ancient trauma. Its magnetic field twisted, its rings dark and haunting, and Voyager flew through a plasmoid, a magnetic bubble, perhaps tearing Uranus's atmosphere away into space. And Neptune, Neptune, blue as Earth, but wild, winds at 1,500 miles per hour. A storm, the great dark spot swirling like a planetary hurricane the size of Earth. We thought Neptune would be boring. Voyager showed us a symphony of chaos. But the most profound moment wasn't a planet. It wasn't a discovery. It wasn't a storm. It was a photograph. As Voyager 1 left the solar system, it turned its camera back at Carl Sagan's request and took one final image. Earth, from 3.7 billion miles away, a pale blue dot, suspended in a sunbeam. Every wall, every poem, every cry of joy, on a pixel smaller than a grain of sand. And then, Voyager shut its eyes. To conserve power, it turned its cameras off, and it listened, because the mission had changed. It was no longer just about planets. Voyager had become something else. A sentinel, drifting into interstellar space. A lonely ambassador from a fragile world, bearing witness to the silence between stars. Today, the Voyager probes still whisper across the void, their voices carried on radio waves weaker than a watch battery. It takes nearly a day for their signals to reach us, but they are still speaking, and perhaps one day, someone else will listen. Maybe not tomorrow, maybe not in 10,000 years, but someday, in the unfathomable future, a mind may find that golden record and hear the sounds of Earth, of waves, of laughter, of music, of breath, and in that moment, Earth will not be forgotten, because Voyager carries more than data, it carries hope. What if the most violent force in the solar system was also its guardian angel? From a distance, it looks like art, swirling colors, majestic bands, a ballet of clouds painted in crimson and gold. But don't be fooled. Jupiter is not a painting. It is a predator, a king, a war god, the largest planet in our solar system, 318 times more massive than Earth, more than twice the mass of all other planets combined. It doesn't have a surface. It has layers of rock, and beneath its beautiful mask lies a chaos we are only beginning to understand. Voyager was the first to pull back the curtain. In 1979, as Voyager 1 raced past Jupiter, it captured something we had never seen before, something Earth-based telescopes could only dream of. Io, one of Jupiter's moons, erupting. Not quietly, not subtly. It was exploding. Molten plumes of sulfur rock jetted 190 miles above the surface, spraying lava across a tortured landscape. It was the first time we'd witnessed volcanic activity beyond Earth, and it shattered our assumptions. Moons weren't supposed to do that, but around Jupiter, the rules are different. Io is just the beginning. There are over 90 moons, orbiting this giant, each a world of its own, each a possibility. Europa, smooth and bright, hides an ocean of liquid water beneath its frozen crust, an ocean twice the volume of all Earth's oceans combined. Cracked ice plates suggest tidus, motion, even heat, and where there is heat and water, there might be life. Then there's Ganymede, the largest moon in the solar system, bigger than Mercury, with its own magnetic field, possibly generated by a liquid iron core. And Callisto, ancient and cratered, like a fossilized memory of the early solar system. Jupiter doesn't just hoard moons. It builds empires around itself. But the heart of the giant is its atmosphere. Those vivid bands of color reds, browns, whites, yellows are jet streams, some moving in opposite directions at speeds up to 223 miles per hour. Storms rage across latitudes, trapped between belts, feeding on heat and momentum. And in the southern hemisphere spins the most terrifying weather system ever discovered, the Great Red Spot, a storm larger than Earth, a cyclone that has raged for centuries, maybe thousands of years. Winds inside it reach 400 miles per hour. Clouds tower 5 times higher than Mount Everest. It rotates counterclockwise, like a planetary wound that refuses to heal. And yet, Voyager showed us it wasn't alone. Other smaller storms danced nearby, white ovals, brown barges spinning, colliding, consuming one another like celestial predators. Jupiter is a storm factory. It breathes chaos. It wears fury like a crown. But the real secret isn't in what we see. It's what we can't see. Beneath those clouds, pressures increase exponentially. Hydrogen, the lightest, most abundant element in the universe, begins to change. It becomes metallic, not metaphorically, literally. Under millions of atmospheres of pressure, hydrogen atoms are crushed so violently that their electrons are forced to roam free, creating a metallic liquid, a planetary ocean of metal. This ocean conducts electricity, and that turns Jupiter into a cosmic dynamo. Its magnetic field is 20,000 times stronger than Earth's. It stretches millions of miles into space, sweeping up charged particles like a vacuum. And in that magnetic grip, Jupiter becomes a killer. Any spacecraft or human that gets too close would be fried by radiation. Some of its moons, including Europa, are constantly bombarded by this electromagnetic wrath. Jupiter doesn't ask for worship, it demands distance, and yet, this violent force may have saved us. For centuries, Jupiter has acted as a cosmic shield, its massive gravity pulling in asteroids, comets, and interstellar debris that might otherwise have struck Earth. It has taken the hits so we didn't have to. The most dramatic proof? Shoemaker-Levy-Deviate. In 1994, astronomers watched as a shattered comet, broken by Jupiter's tidal forces, slammed into the gas giant piece by piece. The impacts left dark scars in Jupiter's clouds larger than Earth. If that comet had struck Earth instead, the damage would have been biblical. Some scientists now believe Jupiter may be responsible for Earth's very habitability. Without it, the constant bombardment during the early days of the solar system might have sterilized our planet before life could even begin. Jupiter, in all its fury, might be the reason we're here. It is both destroyer and protector, a god with two faces. Then came Juno. In 2016, this $1 billion solar-powered spacecraft arrived to finish what Voyager started. It flew closer than anything before it, dipping just 3,000 miles above the cloud tops, taking images so detailed they looked like oil paintings, bands of color, cyclones at the poles, hexagonal storms, like geometry carved in vapor. Juno revealed that Jupiter's atmosphere is 1,800 miles deep, far deeper than we imagined. It found massive cyclones at the poles, each the size of continents, swirling in perfect patterns, like a planetary mandala. It discovered that beneath all the chaos, Jupiter might be one single body, rotating as one no solid surface, just an endless, spinning core of motion. And yet, we still don't know if it has a solid center, a rocky heart, an origin. Jupiter remains a mystery, a living paradox. So what is Jupiter? A planet? A storm? A shield? A graveyard of failed moons? Maybe it's all of those things, or maybe it's something else entirely. A cosmic warning, a reminder that beauty and violence often share the same skin, that the forces keeping us safe are not gentle, but brutal, that in a universe full of chaos, the things that protect us are often the most dangerous of all. And still it spins, still it guards, still it watches, not because it must, but because that's what giants do. What if the most Earth-like world in the solar system wasn't Earth at all? We chase beauty in the cosmos. We name the stars, we sketch the planets, we build myths from their orbits. But in all the heavens, few sights rival the wonder of Saturn. Saturn is elegance made visible, a sphere of gold, suspended in darkness, encircled by halos of shattered light. Its rings, billions of icy particles, aren't just beautiful, they're ancient, they're violent, and they shouldn't exist. They orbit too perfectly, they shine too brightly, they're too fragile to last billions of years, and yet they remain. Like a ballerina dancing in slow motion, Saturn twirls at the edge of time, defying decay. But Saturn is more than its rings. It is a system, a kingdom of moons, mysteries and myths, and among them one stands apart. A world with rain, a world with rivers, a world with an atmosphere and oceans. This is Titan, and it may be the strangest, most important moon in the solar system. Titan is Saturn's largest moon, bigger than Mercury, cloaked in an orange haze so thick that sunlight barely penetrates. For decades, Titan was a phantom, a mystery wrapped in clouds. We knew it had an atmosphere, the only moon that does, but we didn't know what hid beneath the smog. Then came Cassini. In 2004, after a 7-year journey across the solar system, the spacecraft entered Saturn's orbit, and a year later, on the 14th of January, 2005, it deployed a probe Huygens that parachuted through Titan's atmosphere and landed on its surface. For a few hours, Titan stopped being theory and became real. The images were shocking, not because they were dramatic, but because they were familiar. Shorelines, riverbeds, eroded stones, vast plains stretching into a horizon bathed in gold. It looked like Earth, but it wasn't water that had carved this landscape. It was liquid methane and ethane, raining from hydrocarbon clouds, pooling into seas of frozen gas. Titan rains fire, and yet it flows like Earth. This is the great paradox of Titan. It's so alien, it should terrify us, and yet it feels oddly comforting. Its atmosphere is 4 times thicker than ours. You wouldn't need a pressure suit, just a warm jacket and a respirator. Its gravity is so low that you could strap wings to your arms and fly. And beneath its crust hides something even more impossible: a subsurface ocean of liquid water and ammonia. Cassini's radar and gravitational data suggest this ocean spans the entire moon, hidden beneath a shell of ice. And where there's water, there may be life. But this life would not be like us. It wouldn't breathe oxygen. It wouldn't swim in blue seas or bask in starlight. It would be born in shadow and frost, thriving in liquid hydrocarbons, fueled by alien chemistry. And it may already exist. In 2016, scientists found something in Titan's upper atmosphere that stunned them. A molecule called cyclopropanylamidine, C3H2. It had only ever been detected in deep space clouds. It doesn't exist naturally on Earth, and yet here it was circling Titan. C3H2 is a closed-loop organic molecule, a carbon ring. That's important because ring structures are the backbone of DNA and RNA, the building blocks of life. No one knows what's creating C3H2. It's unstable. It shouldn't last long. Something is making it. It could be chemistry. It could be biology. And if it's biology, Titan may hold the second genesis, a completely independent origin of life, not based on Earth, a cosmic sibling we never expected to find. NASA took this seriously. In 2019, they announced a mission unlike anything before: Dragonfly, a nuclear-powered drone designed to fly from place to place across Titan's surface. Not a rover, not a lander, a flying laboratory. Slated to launch in 2027 and arrive by 2036, Dragonfly will explore dunes, coastlines, and impact sites, searching for complex organic molecules, studying Titan's weather, and diving deep into its chemistry. It will carry a radioisotope thermoelectric generator, using decaying plutonium to power flight after flight in Titan's dense, calm atmosphere. Where Mars rovers crawl, Dragonfly will soar, and it will land at night, charge in the sunlight, and bounce from biome to biome in search of the answers Earth cannot give us. But this is not just about science. Titan is philosophical. It forces us to ask, what is life really? Does it require water, oxygen, warmth, or can it be something stranger, colder, more alien than we're prepared to accept? If life exists on Titan, it didn't evolve the way we did. It would mean life is not rare. It's woven into the very physics of the universe. It arises wherever the conditions, however extreme, are met. Titan reminds us that biology is not sacred. It's opportunistic. It's adaptable. It's inevitable. And perhaps Titan is not just an object of study. Perhaps it is a destination, Some scientists believe Titan may be a better candidate for colonization than Mars. Its atmosphere shields from radiation. Its resources are abundant. Its potential is profound. Imagine humans flying across orange skies, building cities beneath methane rain, studying alien biology from inside shimmering domes. It sounds like science fiction, but it's only a few decades away. Saturn is the king, but Titan may be the heir. A world hidden in fog, waiting for a visitor to lift the veil. We once thought moons were dead. Now we know they might be gardens. Titan may not just reflect Earth's past. It may foreshadow its future. A place where chemistry became complexity, where complexity became life, and where life, if it exists, has been waiting, not for rescue, but for recognition. What if the quietest planets held the loudest secrets? Beyond Saturn, the solar system goes cold, the sunlight thins, the shadows stretch, and the planets turn pale, distant, and forgotten. For centuries, Uranus and Neptune were little more than blue blurs in telescopes' afterthoughts, placeholders at the edge of the known. Even when Voyager 2 flew past them, NASA almost didn't bother. Funding was tight, expectations were low. They're just frozen gas balls, they said. What could possibly be interesting? But space doesn't care about our expectations. And as Voyager 2 approached the 7th and 8th planets from the Sun, the silence cracked open, and we listened. Uranus is the oddball of the solar system. It doesn't spin upright like the other planets. It rolls sideways, like a marble knocked over by a cosmic hand. Its axial tilt is a staggering 98 degrees, as if it's lying on its side, tumbling through space. Why? No one knows for sure. Maybe a primordial collision, a rogue planet that struck Uranus early in its formation, scarring it forever. Or maybe something deeper, something in its core misaligned, broken, or chaotic. Whatever the reason, Uranus is tilted against everything, against symmetry, against expectation, against the solar system's rules. Its seasons are extreme. Each pole gets 42 years of unbroken daylight, followed by 42 years of darkness. Its rings narrow, dark, and eerie encircle it vertically, like the planet wears a halo turned sideways. And the winds? Despite its distance from the Sun, Uranus has winds that reach 560 miles per hour. Its upper atmosphere is composed mostly of hydrogen, helium, and methane, which reflects sunlight as a pale cyan blue. But beneath that stillness hides something stranger. In 1986, Voyager 2 swept past Uranus. It was a quick pass, just 45 hours of proximity. But decades later, scientists revisiting the data saw something they'd missed. A sudden jolt in the magnetic field, a 60-second ripple, an invisible bump in the road. It wasn't noise, it wasn't error. Voyager had flown through a plasmoid, a giant magnetic bubble, torn from Uranus's atmosphere and flung into space. This discovery changed everything. It means Uranus is leaking, bleeding air into the void, not just through evaporation, but through magnetic ejection. Earth does this too gently, slowly. But Uranus? It rips open its sky and throws part of itself into the dark. If Uranus is the strange sibling, Neptune is the silent sorcerer. It's 30 times farther from the Sun than Earth, and yet it howls. Winds scream at 1,500 miles per hour, the fastest in the solar system. These aren't breezes. They're supersonic jet streams, racing through methane clouds and spiraling into madness. How can a planet so far from the Sun, so cold, so distant, generate storms so powerful? We don't know. We're not even close to knowing. But Voyager 2 gave us a clue. The Great Dark Spot, a massive, Earth-sized hurricane dark, rotating, ominous, appearing suddenly in Neptune's atmosphere, like an eye opening in the deep. And just as mysteriously, it vanished. Later observations showed the spot was gone, dissipated, relocated, or transformed. But others appeared in its place. The planet breathes in storms, like thoughts appearing and disappearing in the mind of a giant. Uranus and Neptune were once thought to be gas giants like Jupiter and Saturn, but they're not. They're ice giants, a different class entirely. Their cores are denser, their interiors are rich with water, ammonia, methane, and exotic ices, not frozen in the way we know them, but pressurized into weird states of matter. Inside Neptune, water may exist in a supersonic state, a form of ice where oxygen atoms lock into a crystal, while hydrogen ions flow freely, conducting electricity like metal. This isn't just ice, it's alien physics, something we've only simulated in labs, and Neptune lives it. Both Uranus and Neptune have wild, lopsided magnetic fields. Unlike Earth, where the magnetic poles are near the geographic ones, these ice giants are a mess. Uranus's magnetic field is offset by a third of the planet's radius and tilted 60 degrees from its axis. Neptune's is tilted 47 degrees and also off-center. This makes their magnetospheres wobble, twist, and tumble as the planets rotate, creating auroras that dance in chaotic spirals, lighting up the polar regions in unpredictable flashes. It's as if the planets are trying to contain a force they barely understand, or perhaps one we don't. Since Voyager's flybys, no spacecraft has returned to Uranus or Neptune. We've sent rovers to Mars, orbiters to Jupiter, probes to the Sunday. But these two ice giants wait in silence, and yet they may hold the keys to planetary evolution. They may reveal how gas giants form, how atmospheres break apart, how magnetic fields shape the birth of moons. They may even hint at how life survives without light. For beneath those clouds, if heat and chemistry dance together, there may be ocean layers, warm and pressurized, hidden in the dark. They could harbor life, or clues to life, or nothing at all. But even that, the absence is an answer. Uranus and Neptune orbit in the twilight of the solar system. They mark a threshold, a place where gravity weakens, where light fades, where certainty ends. They are the guardians of the edge, and the bridge to the beyond. When Voyager passed Neptune in 1989, it looked back one last time. It had seen all four outer giants. It had witnessed storms, rings, moons, madness. Now, it turned toward the stars. Behind it, the solar system. Ahead, forever. What if the most important discovery was that there is no edge at all? There is a boundary not of matter, but of meaning. A place where our sun's influence fades, where its winds grow still, where the voice of the star that raised us becomes a whisper. That place is called the heliopause, and Voyager crossed it. The year was 2012, 35 years after launch. After Jupiter's moons, Saturn's rings, Uranus's tilt, and Neptune's storm, Voyager 1 had reached the edge of the solar system. Not the edge of orbit, not the edge of planets, the edge of influence. Because the solar system is not just planets, it is not just rocks and gas and moons. It is a bubble, a fragile, invisible shell carved out by the solar wind, the stream of charged particles ejected by the Sunday. That bubble is called the heliosphere, and it extends 11 billion miles in every direction. Within it, the sun is king. Its magnetic field dominates. Its particles reign. But beyond, lies interstellar space, the realm between stars, the ancient ocean of radiation, dust, and forgotten atoms untouched by any star's breath. On the 25th of August, 2012, Voyager 1 left the sun's cradle and entered the great unknown. It didn't cross a wall. It didn't pass a sign. It simply felt a change. The solar wind vanished. Cosmic rays from deep space surged. The plasma, the ionized soup of the galaxy, changed character. Voyager had crossed the termination shock, where the sun's wind slows dramatically, then the heliosheath, where it begins to mingle with the interstellar medium, and finally the heliopause, the boundary itself. And suddenly, the spacecraft was no longer in the solar system. It was between the stars. Here's the miracle. It still speaks. With a 23-watt transmitter weaker than a refrigerator bulb, Voyager 1 beams signals across billions of miles. It takes over 20 hours for the message to reach Earth, but we hear it. The Deep Space Network, a system of massive radio antennas across Earth, listens to Voyager's heartbeat. It's a whisper, a flicker, but it's there, and what it tells us is stunning. We once imagined interstellar space as empty, a void, a silence. But Voyager found pressure, particles, and plasma, not warm, but hot 54,000 degree Fahrenheit, not because it's dense, but because it's fast. The particles are thin, but moving at tremendous speeds. Voyager 2 confirmed it in 2018, becoming the second human object to enter interstellar space, and this time with a working plasma wave instrument. It heard a hum, a steady, low-frequency vibration, the song of the galaxy. This wasn't noise. It was the background radiation of space, the interstellar medium, singing across frequencies like a giant, breathing organism. Voyager wasn't just drifting, it was swimming. When Voyager launched, Jimmy Carter was president. There were no smartphones, no internet, no Hubble, no Elon Musk. Voyager has outlived presidents, empires, and ideologies. It was built to last 5 years. It's lasted over 45. Its cameras are off, its instruments slowly failing, but its spirit, unbroken. It runs on a radioisotope thermoelectric generator, converting the heat of decaying plutonium-238 into electricity. Each year, it grows dimmer. By the 2032nd, its instruments will go silent, and then it will drift alone, unseen, unheard, but never lost, because it carries our fingerprint. On board each Voyager is a golden disc, etched with care, coated in gold. It contains 115 images of Earth, from DNA strands to human anatomy to street scenes, 55 greetings, in languages from Sumerian to English to whale song, sounds of thunder, bird song, a baby crying, music Bach, Beethoven, Blind Willie Johnson, and a Navajo chant, a message from then-President Jimmy Carter. This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts and our feelings. It is a message in a bottle, hurled into a dark sea with no recipient in mind. But perhaps that's the point. Voyager carries not just data, not just signals, it carries hope that someone might find it, that intelligence might not be alone, that memory can outlast flesh. Right now, Voyager 1 is more than 15 billion miles from Earth, traveling at 38,000 miles per hour, heading toward the constellation Ophiuchus. Voyager 2 trails behind, heading toward Sagittarius. In 40,000 years, they'll pass within a light year of other stars. Long after Earth has changed, long after continents shift and languages fade, Voyager will continue, no longer a mission, now a myth. The first thing humanity ever built that left home and never looked back. When Voyager left the solar system, it didn't just cross a boundary, it redefined one. It proved that we could extend consciousness beyond the light of our Sunday, that we could touch forever, not with hands but with intention. Voyager is not just a spacecraft, it is a prayer cast into the void, a song sung with no guarantee of being heard, and yet we sing it anyway. Because wonder is not optional, it is essential. We are not meant to stay in the cradle forever. We are made to ask, to reach, to cross the threshold. There's a poem hidden in Voyager's path. We began in stardust. We formed bones and breath. We looked up. And then we launched. Not to conquer, but to connect. And somewhere, billions of miles away, 2 tiny beacons blink in the dark, reminding the galaxy and ourselves that even the smallest voice can echo into eternity. What if the secret to life on Earth is frozen on another world? It begins with a whisper, a strange molecule in the clouds, a ring of carbon atoms, dancing alone through orange air. Something never seen on Earth, only deep in the vacuum of space. And yet here it was hovering over the surface of Triton. What was it doing there? It wasn't alive, but it was trying to be. NASA saw the signal, paused, and then answered with a plan bold enough to match the mystery. Send something that flies. Not a rover, not a lander, a drone, a robot with wings, to explore Titan's alien landscapes from above, like an insect over an alien Earth. They called it Dragonfly. And if it works, it could change the very definition of life itself. Dragonfly isn't science fiction. It's already being built. A car-sized quadcopter drone with 8 rotors, Dragonfly is designed to hop from place to place, flying hundreds of kilometers across Titan's frozen plains and dunes. Why fly? Because Titan invites it. Its gravity is only 1/7 of Earth's. Its atmosphere is denser than ours, like a dream for aviation. If you had wings strapped to your back, you could fly there with muscle power alone. So NASA decided to do what no one's done before: fly a spacecraft through the atmosphere of another world. Dragonfly will launch in 2027 and arrive by 2036. It will ride aboard a rocket, then separate, then slow itself in Titan's atmosphere with a parachute, before firing its rotors and touching down gently on the ground. From there, it begins its 2.7-year mission. Each Titan day, it will soar across the moon's surface, gathering samples, analyzing chemistry, and sending the data home. Its power comes from a radioisotope thermoelectric generator, a small nuclear battery using the decay of plutonium-238 to provide heat and electricity, even in Titan's frigid 290-degree Fahrenheit landscape. And because it can fly, Dragonfly can navigate to sites of scientific interest: impact craters, ancient shorelines, hydrocarbon lakes, and even potential cryovolcanoes. No tracks, no limits, just sky. Dragonfly isn't looking for little green men, it's looking for organic complexity. On Titan, hydrocarbons fall from the sky like snow. Methane and ethane form rivers and lakes. Water, locked beneath the crust, lies waiting in silence. And in this cauldron of carbon and chemistry, scientists suspect a form of prebiotic evolution could be underway. Think about it. Earth's first life didn't appear in sunlight and forests. It began in mud and fire, in deep-sea hydrothermal vents, among minerals, pressure, and heat. Titan has similar conditions. It has energy, it has complex molecules, and it has time: billions of years of stillness and simmering chemistry. What Dragonfly hopes to find is not life itself, but evidence of life's potential. Something we've never seen outside Earth. Organic compounds organizing themselves, molecules that react, replicate, or even compute. The early whispers of a new biochemistry. If Dragonfly finds that, it will mean that life is not a miracle. It's a pattern, a chemical inevitability in the right environment. And that pattern might be playing out right now, on a moon orbiting Saturn. Here's why it matters. So far, all life we know shares one origin: Earth. Even the weirdest bacteria here use DNA, proteins, and lipids. They evolved from the same ancestral cell. But what if Titan has life that's entirely different? Built from methane instead of water, using hydrocarbons instead of sugars, encoding information not in DNA, but something we've never seen. That would be a second Genesis. Independent, alien, a separate spark in the dark. And it would mean the universe is alive not by accident, but by design. It would mean biology is not Earth's story. It is the universe's language. Dragonfly won't be alone. It will be accompanied silently by Earth. Every flight, every landing, every sample will be beamed back to us with a 90-minute delay. Scientists will watch from mission control as the drone touches down in alien sand, drills into ancient ice, and scans for molecules that could rewrite our understanding of what life island. And it won't be still. Every Titan day, Dragonfly will lift off again, avoiding dust storms, chasing sunlight, and heading toward new targets. Eventually, it will reach Selk Crater, an impact basin where water, heat, and organics may have once mixed violently. If life ever began on Titan, Selk is where it may have begun, and Dragonfly will land in its center. What Dragonfly might find is not bacteria, or fossils, or even living cells. It might find the shadows of life molecules on the edge of animation, chemical pathways forming, reforming, organizing, the prelude to biology. This is where the story gets cosmic, because if Titan's chemistry is on the cusp of life, then maybe Earth's early oceans weren't unique. Maybe they were just one expression of a universal pattern. And that means we are not special, we are early. The universe may be filled with Titangent-like worlds, each brewing its own recipe for consciousness. waiting for time, chance, and a spark. Dragonfly isn't just about science, it's about perspective. We sent a machine to fly on another world, to chase a molecule in the mist, to test a hunch that maybe, just maybe, life isn't rare, it's restless. And if it finds even the hint of life's logic in Titan's frozen haze, it will mean that Earth was not the beginning. It was just the first verse. Somewhere, in a clean room on Earth, Dragonfly is being assembled. One day soon, it will ignite its rotors, dive through Titan's orange sky, and land on a world that has never been touched by life as we know it. It will listen, it will sniff, it will fly again, and it might bring back not just data, but a new genesis. What if, beneath the clouds of a planet, was the largest ocean in the solar system, and it wasn't made of water? We thought we knew Jupiter. We thought we had seen its worst, the great red spot, the crushing atmosphere, the moons of fire and ice. But in 2016, something arrived that would challenge everything we believed. Juno, a spacecraft named after the Roman goddess who could see through the clouds. Juno was designed not to orbit safely at a distance, but to dive headfirst into Jupiter's wrath. It would skim just 3,000 miles above the cloud tops, closer than any probe had dared. Why? Because Jupiter still held secrets. Because even after centuries of study, we didn't know what it was. Was it hollow? Did it have a core? How deep did the storms go? Juno would find out, and what it discovered was nothing short of terrifying. When Juno looked at Jupiter's north pole, it saw something no one expected. A hexagon of cyclones, each the size of a continent, spinning in place, locked in a geometric pattern, like gears in a celestial machine. Not chaos, but order. Not random weather, but architecture. At the South Pole, the same another vortex, surrounded by 5 massive cyclones, all swirling in a precise spiral. This wasn't meteorology. This was design on a scale we had never imagined. And deeper still, the storms didn't end at the clouds. Juno found that Jupiter's famous bands, those beautiful stripes of white and red, weren't just surface features. They extend 1,800 miles deep. That's 60 times deeper than Earth's atmosphere. Each band holds 3 Earth masses of gas. These are rivers of hydrogen, moving in opposite directions, swirling with such force they reshape the entire planet's gravity field. As Juno probed deeper with microwaves, it found something even stranger. Jupiter's atmosphere doesn't fade into a solid core. Instead, it melts into something new, a planetary ocean. But this is no ocean of water. It is made of liquid metallic hydrogen. Under the crushing pressure of millions of atmospheres, hydrogen, the simplest atom in the universe, transforms. Its electrons break free. It behaves like a metal. It flows like a sea. And this ocean doesn't just sit still. It spins. It generates currents. It becomes a giant dynamo, producing a magnetic field so strong it deflects solar wind millions of miles into space. Juno measured this field, 20,000 times stronger than Earth's. It found hotspots, magnetic anomalies, and a warped asymmetrical structure that scientists still can't fully explain. Jupiter doesn't just have a magnetosphere. It has the most powerful magnetic engine in the solar system. And that magnetosphere is not gentle. It is violent. It traps particles and accelerates them to near light speed, creating belts of radiation so intense that if you flew a spacecraft through them unshielded, it would be vaporized in hours. Jupiter's magnetic field has shape, it has motion, it has sound. Juno converted some of the magnetic data into audio, revealing eerie wails and chirps that echo like the calls of deep space whales. It's beautiful and haunting because these are the songs of charged particles trapped in Jupiter's grip, circling endlessly in spirals of doom. This magnetic field isn't just a shield, it's alive. It has personality. It changes. It pulses. It breathes. And it's one of the reasons Jupiter may have saved Earth. Its magnetic bulk may have deflected early solar flares, ejected comets, and cleared the path for a stable inner solar system. In that sense, Jupiter is both guardian and executioner. But Juno didn't just look inward. It also studied Jupiter's moons. Io, the most volcanically active body in the solar system, literally sprays material into Jupiter's magnetic field, feeding it. This creates a ring of plasma, an electric current, so powerful it links Io and Jupiter in a cosmic circuit. It's like a moon plugged into a planet. And then there's Europa, Ganymede, and Callisto worlds with icy crusts and potential oceans beneath. Jupiter may not just have one ocean inside itself. It may host multiple oceans on its moons, and Juno's data will help determine where we look next for life, for clues for the future. Juno measured Jupiter's gravity field with such precision that it could detect slight wobbles as the planet rotated. What it found was surprising. Jupiter might have a solid core, but it's not compact. It's fuzzy, diffuse. Instead of a dense rock at the center, the core may have melted and mixed with the surrounding hydrogen. This would mean that Jupiter's early formation was far more violent than we imagined, possibly involving collisions with other protoplanets, fragmenting and scattering its interior like a shattered heart. Jupiter is not one thing. It is a spectrum of possibilities, layered in mystery, wrapped in storms. Juno's images are not just data. They are paintings in motion. They show clouds billowing in 3D, colors twisting into spiral arms, storms nesting inside storms. One image captured lightning in Jupiter's polar night, illuminating clouds with brief flashes like a heartbeat in darkness. Another revealed blue storms, unlike anything seen on Earth. And at the planet's poles, no red spot, no bands, just pure chaos, like looking into the eye of a gas giant's soul. Juno isn't just teaching us about Jupiter, it's showing us what giants really are. That beneath beauty lies brutality, that creation required destruction, that order can emerge from madness, and maybe most importantly, that planets are not done evolving. Jupiter is still changing, still generating heat, still forming storms, still teaching us that even the oldest gods have secrets. Somewhere above those clouds, Juno still orbits. Every 53 days, it swoops in, listens, measures, transmits, and then vanishes into the radiation belts, praying its instruments hold. But when it dives, so do we, because Jupiter is not a destination, it's a revelation. They used to laugh when scientists warned about the sky. The idea that a rock from space could end life on Earth, it felt like fiction, like a story told to children around a fire, not something worthy of serious minds or billion-dollar budgets. But then something happened, a moment that changed everything, a moment when the cosmos reminded us just how fragile we are. It began with a comet cold, ancient, forgotten, slipping through the void. Its name was Shoemaker Levy 9, a broken, wandering thing, barely holding itself together. Caught in Jupiter's gravity, it didn't just orbit, it shattered. The tidal forces tore it into more than 20 fragments, each one a bullet forged in silence. They lined up like pearls on a string, a cosmic freight train heading straight into a monster. Astronomers watched with awe and dread as one by one, over several days in July 1994, the fragments plunged into Jupiter's atmosphere. Each impact released energy equivalent to millions of nuclear bombs, carving dark bruises into the giant's clouds, scars larger than Earth. For the first time in human history, we witnessed a planetary collision in real time. It was beautiful, it was horrifying, it was humbling, because that could have been us, if Jupiter hadn't intercepted it. If that trajectory had been aimed just a little closer to the Sun, one of those fragments could have struck Earth. And if it had, everything we know, cities, languages, memories, could have ended in a flash of fire and dust. Shoemaker Levy 9 wasn't just a comet, it was a message, a reminder, a cosmic bullet we watched from the safety of distance, too stunned to speak, too mesmerized to look away. And it wasn't the only one. In the decades since, astronomers, amateurs, and professionals alike have spotted other flashes, brief white bursts in Jupiter's clouds, sudden impacts from small asteroids or unknown debris. Each one is a testament to the giant's gravitational pull, to its silent duty as a planetary shield. Because Jupiter is more than a planet, it is a sentinel, Its gravity is so immense it dominates the architecture of the solar system. It sculpts the orbits of asteroids, shepherds the comets, and even clears space around the Earth's neighborhood. Without it, the early solar system might have been an uninhabitable shooting gallery, every young world bombarded, sterilized, reset before life could take hold. But because Jupiter was there, because it absorbed the chaos, Earth got time to cool, time to grow oceans, time for molecules to dance into life, time for us. And now, with every image, every probe, every new observation, we are beginning to understand the true scale of what this giant has done. It's not just that Jupiter protects us, it's that it protects us without our asking, without our awareness, without gratitude. It simply stands at the gate and takes the hits. And that raises a question so big, so quietly terrifying, it almost feels wrong to ask, what happens when it misses? Because it only takes one fragment, one object, one forgotten speck of rock tumbling through the dark, unclaimed by gravity, unseen by our telescopes, until it's too late. The next Shoemaker Levy 9 might not shatter, it might not be diverted, it might not aim for Jupiter, it might aim for us. And that is why we look, that is why we watch, not out of fear, but out of reverence, because now we know we're not immune. We're not above the laws of physics or probability. We're riding a fragile blue dot through a cosmic shooting range, and we're alive because, for the moment, the giants are standing between us and the bullets. But this isn't a story of doom, it's a story of awareness. The Shoemaker Levy 9 impact sparked a global awakening. Governments funded planetary defense programs. Telescopes were built not just to admire the stars, but to track the shadows moving among them. Scientists began modeling trajectories, calculating impact risks, and designing mitigation strategies. The laughter faded. The warnings became blueprints. And at the heart of that shift was Jupiter, the gas giant that bled for us. Now we honor it not just with photographs, but with gratitude. We've seen how it absorbs punishment, how it swallows fire, how it stands as both destroyer and savior. It taught us humility. It taught us vigilance. It taught us that even in a universe indifferent to our survival, there can be patterns of protection, unconscious guardianship, silent mercy, written into the orbits of the heavens. And maybe that's the point. Maybe the universe isn't safe. Maybe it never was. But within that danger, there are structures that sustain us. Magnetic fields that shield, moons that stir oceans, giants that catch the bullets meant for smaller worlds. And maybe, just maybe, the fact that we can even tell this story, that we can sit here in a moment of peace, tracing the trajectories of comets and remembering the scars on Jupiter's skin, is itself a kind of miracle. We are still here because something bigger than us took the fall. So look up, look often, because in the swirling clouds of Jupiter, the echoes of our survival still glow. There are things we can't describe, only show. No equation can capture the way Saturn's rings shimmer against the void. No language can translate the silence of Mars at dusk. No lecture can explain the way Earth looks from space, vulnerable, spinning, perfect. Sometimes, science must become art, and so we built cameras for gods, orbiters, rovers, probes, telescopes, and sent them into the dark with one instruction: show us what's really out there. And they did. What came back were not just pictures. They were revelations. The sun was the first to astonish us. We thought we knew it, that comforting fire in the sky. But when we turned our telescopes on it, filtered, tuned, armored against its fury, what we saw was not peace, but violence. Solar filaments arched like titanic whips. Prominences rose and collapsed like towers of flame. Coronal mass ejections hurled billions of tons of plasma into space at nearly 1 million miles per hour. One photo taken in 2012 by the Solar Dynamics Observatory showed a filament that stretched for hundreds of thousands of miles, an arc of light and fury dancing in the sun's atmosphere, before breaking loose and vanishing into space. That's not just weather, that's creation's heartbeat. Then came Mercury, closest to the sun, scarred and cratered like a planet abandoned by time. It looks like our moon at first glance, but high-res images from NASA's Messenger spacecraft revealed something else. Ridges, cliffs, and mysterious dark patches that may be remnants of ancient volcanic eruptions. In its final moments, main Voyager sent back one last image, a silent postcard before crashing into the surface, a final glimpse of a world scorched by proximity and solitude. Then Venus-Earth's twisted twin. In 1982, the Soviet Venera 13 lander touched down and survived for 127 minutes in 880 Fahrenheit heat and crushing pressure. What it sent back was unimaginable. A color photo from the surface of Venus' pale stones under a burnt orange sky, a place that once may have had oceans, now a furnace. The image is quiet, but it screams. And then Earth. Every satellite, every mission, has looked back at some point, and when they do, they show us ourselves in ways we never expected. From 22,000 miles up, Earth looks like a jewel, blue and white, alive, spinning. One image, taken by NASA's MODIS instrument, shows the Americas in full daylight, weather patterns swirling over the Atlantic, the shadow of the moon visible in a solar eclipse. Another, captured by the Electro-L Russian satellite, offers a frame so detailed it feels like a living globe. Every continent, every cloud, one side of the entire world in a single frame. But no image moved us like the pale blue dot. Voyager 1, 3.7 billion miles away, turned back before shutting off its cameras. Earth is barely a pixel, caught in a sunbeam. That's it. Everything we are, everyone we love, every story, every war, every song in a dot so small it could vanish in a blink. From there, Earth becomes fragile, precious, unrepeatable, and yet, it's not the only one with beauty. The moon, our first cosmic companion, a desolate world of grey dust and frozen silence, but also the place where human boots first touched another world, where shadows stretch for miles. Where Earthrise was first seen, not as an abstract shape, but as a blue orb floating over the lunar horizon. That photo, taken by Apollo 8, might be the most important image ever captured. It made Earth small, and in doing so, made it sacred. Then came Mars. So many missions, so many images, but one rover changed everything. Curiosity. In 2013, it sent back a selfie, a panoramic mosaic composed of over 1,000 high-resolution images. A robot standing alone on a red desert under a salmon-colored sky. Not just machinery, not just data. It felt like presence, like we were there. That image didn't just show us Mars. It showed us who we've become. A species capable of curiosity so relentless, it builds machines to breathe on other planets. Then came the giants. Jupiter, immense, mysterious, alive with storms. The Juno spacecraft sent back images of cloud tops that look like Renaissance paintings, swirls of cream and crimson, tempests frozen mid-dance. One photo taken from just 5,600 miles above the Great Red Spot revealed its structure in stunning detail. It isn't just a red blur, it's a cathedral of motion, layered, textured, alive. At the poles, Juno found storms shaped like flowers, cyclones forming hexagons, spiraling in crystalline symmetry. Saturn, too, delivered elegance beyond belief. Cassini, during its mission, captured Saturn backlit by the Sunday. In that glow, its rings revealed structures never seen before, braided patterns, gaps, shadows dancing across Saturn's surface. And behind it, faint and small, Earth, just another spark of light. Triton, Saturn's largest moon, emerged as the only world besides Earth with lakes and rivers, but they're made of methane. And when Cassini dropped the Huygens lander, we saw it firsthand. A stone-strewn plain beneath an amber haze. A shore, not of water, but of something other than Uranus and Neptune, once distant dots, now revealed in color and complexity. Uranus with its cyan sheen, rings seen edge-on, and glowing auroras dancing in ultraviolet. Neptune deep blue, scarred by storms. Voyager 2 revealed its great dark spot, and high winds so fast they defy understanding. And even Pluto, once stripped of its planetary status, gave us the most unexpected surprise. In 2015, New Horizons flew past, capturing a world we thought was inert. Instead, we saw ice mountains, a beating glacier heart, and hints of geological activity. Not dead, just misunderstood. Each of these images, stitched together, tells a truth no textbook can. We are not floating in a static model of 9 planets and a sun. We are spinning through a living gallery, a moving museum of storms, scars, ice, flame, silence, and shadow. A solar system not of orbits and equations, but of stories. Stories told in light, in color, in contrast. Stories that remind us that looking changes everything. We sent cameras, but what came back was meaning. Mars is red, but not for the reasons we first imagined. It's not painted in blood or rusted with fury. Its color is memory, iron oxide, the chemical trace of something once alive, or trying to be. It is the color of stillness after violence, of water that left without warning. But before it vanished, it carved valleys. It left dried up riverbeds and clay-rich basins. It whispered in the soil that it had once tried to nourish something. And maybe it succeeded. Maybe life touched this place long before we arrived. Then came our touch, not with hands, but with wheels. Rovers like Spirit, Opportunity, and Curiosity rolled across its deserts, dragging tire marks across ancient dust. Curiosity drilled into rocks, sniffed the air, and studied sunsets that bled orange into alien skies. But then came Perseverance. It didn't just explore, it searched. It landed in Jezero Crater, where a lake once lived. It carried a helicopter, Ingenuity, the first aircraft to fly on another planet. For the first time, humanity took flight under a different sky. And as Perseverance snapped photos, collected samples, and listened to Martian wind, it felt like something had shifted. We weren't just visiting, we were planting the first seeds of memory. And then we turned outward, where storms have different meanings. Jupiter's moon Io is a world perpetually erupting. Volcanoes that spew sulfur 300 kilometers high, lava lakes that churn beneath frozen crust. Its surface is yellow and red, burned and rebuilt in cycles older than myth. To stand there if you could would be to hear the groaning of a moon that never rests. And then Europa, quieter but more mysterious. Beneath its icy skin lies a saltwater ocean deeper than Earth's. No sunlight reaches it, no wind stirs its waves, and yet it moves. Tidal forces from Jupiter flex its interior like a muscle, warming the water, and maybe, just maybe, feeding life. We don't know what swims in that darkness, but soon we might. NASA's Europa Clipper is coming. We're not done knocking. Saturn's realm is colder, more graceful, but it holds secrets of its own. Enceladus is smaller than our moon, yet it defies explanation. In 2005, Cassini spotted plumes, geysers of water vapor, organic molecules, and salt erupting from cracks near its south pole. We thought it was frozen, but it breathes. Those plumes arc high above its surface, then fall back like snow, a cycle of exhalation and return. Inside, a liquid ocean churns beneath its icy crust, stirred by tidal energy. A world like that doesn't just exist, it remembers. Then there's Titan, Saturn's largest moon. We already visited it once, when the Huygens lander descended through its dense atmosphere, touched down on solid ground, and looked around. What it saw wasn't death, it was something else, familiar, but wrong. There were river channels, but not of water of methane. There were sand dunes, but not of silica, of frozen hydrocarbons. Titan is Earth in a dream, or maybe a nightmare, and yet it calls to us. Soon, Dragonfly, a nuclear-powered rotorcraft, will fly across its skies, sampling the haze, mapping the plains, listening for something that isn't quite silence. As we move further, the sun grows smaller, dimmer, like a memory we carry in our pocket. At Uranus, everything tilts. Its axis is sideways, its rings spin vertically, and its magnetic field dances in spirals. Scientists once thought it was quiet, boring even. They were wrong. Its moons, Miranda, Ariel, Titania, are sculpted with cliffs, canyons, and rift valleys that make Earth's look miniature. Some show signs of resurfacing, meaning heat once flowed or still flows. We used to think the outer worlds were dead. They are not dead. They are whispering. Neptune is further still, bluer than blue, roiling with supersonic winds and unseen tides. Voyager 2 caught a glimpse of its great dark spot, a storm the size of Earth, before it vanished into vapor. Its moon Triton orbits backwards, a captured world, retrograde and haunted. It has cryovolcanoes eruptions not of fire, but of liquid nitrogen. Its surface is smooth, sculpted by something unseen. Neptune taught us that distance does not mean silence. It means mystery with more patience. And above all of this, beyond the orbits, past the planets, we float in a solar system stitched together not just by gravity, but by story. Every world is a chapter. Every mission is a footstep in a place no foot has touched. We send machines because we are still learning how to send ourselves. We look through lenses because our eyes aren't ready yet. But the universe is letting us peek, letting us dream, and what it's showing us is staggering. Mountains of water ice, oceans beneath crusts, rivers of methane, lightning in sulfur skies, frozen winds moving faster than sound. These aren't footnotes, they're verses. In the grand poem of creation, the solar system is our first stanza, the part we memorize before we dare recite the rest. And in that poetry, one truth keeps repeating. We are surrounded not by emptiness, but by invitation. The void is not silent. It is asking us to come closer, to understand, to remember, to write the next line. We began this journey asking what's out there. But what we've discovered through dust storms and solar flares, frozen oceans and forgotten moons, is something far stranger. What's out there is what's in here. The solar system is not just a sequence of planets. It's a mirror, a riddle, a challenge. Every crater is a scar in time. Every ring a frozen echo of collisions. Every geyser, every whisper of methane or hydrogen isn't just data. It's a reminder that the universe isn't done with us, that maybe it never started without us. The deeper we look, the more reality twists. It stops behaving like a stage and starts feeling like a story we were born into, but also one we're slowly learning to write. And here's the real secret. We used to think we were looking out from our little blue dot across the stars. But what if we're not looking out? What if we're looking in? Because the solar system isn't just an object, it's a process. It's time stretched out in three-dimensional form. It's memory crystallized in orbits and atmospheres. And the more we observe it, the more it begins to reflect our deepest truths back to us. Mercury shows us resilience, blistered, battered, but still spinning. Venus reminds us that beauty can hide catastrophe, and catastrophe can mask ancient potential. Earth shows us the miracle of balance, so fragile, so brief. Mars, the ache of loneliness and the urge to rebuild. Jupiter, the brute force of protection, swallowing comets that would otherwise destroy us. Saturn, the elegance of rings, harmony born from chaos. Uranus, the courage to spin in your own direction. Neptune, the symphony of unseen forces. And Pluto, exiled, reclassified, misunderstood, but still full of meaning. Each one is a metaphor we haven't finished decoding. Each one is a truth we haven't fully absorbed. And maybe that's the purpose of our exploration. Not just to find life, not just to settle Mars or mine asteroids, but to uncover, piece by piece, the deeper architecture of what it means to be alive in this universe. We used to think space was indifferent, silent, cold, but that's not what the pictures say. That's not what the geysers of Enceladus are telling us. That's not what the dunes of Titan are sculpting. That's not what the ice volcanoes of Triton whisper in their stillness. What the universe is telling us, if we're willing to listen, is that meaning isn't a human invention. It's a property of the cosmos, buried in methane lakes, encoded in magnetic fields, etched into planetary scars. The solar system is alive with metaphor, alive with warning, alive with promise. It tells us that life is rare, that complexity is delicate, that silence is not the absence of voice, but the space where understanding begins. And so we come full circle, back to Earth, back to the only world we know for sure is alive, the only world with oceans and trees and consciousness that wonders where it came from. Maybe that's why we look outward, not just for curiosity, but for comparison, because only in seeing the loneliness of Mars do we understand the lushness of Earth. Only in seeing the chaos of Jupiter do we appreciate the calm we live in. Only in knowing how strange the cosmos is can we begin to understand how precious the ordinary, truly island. We are made of this solar system. We are the children of supernovas, the descendants of dust, the momentary awakening of matter that now asks, what am I? That's the real discovery. Not what we found, but who we're becoming. We built telescopes and probes and rovers to go farther, but the real journey wasn't distance. It was depth. The solar system, for all its moons, storms, ice, and fire, is not a frontier. It's a mirror, and in that reflection we see the beginning of something vast, a new kind of intelligence, a new kind of responsibility, a new kind of belonging. The next time you look up at the night sky, or a photo from Mars, or the rings of Saturn glowing in ultraviolet light, don't just see planets. See yourself, your past, your potential, your place in this impossible orchestra. Because the cosmos is not silent, it's waiting. And the question is no longer, are we alone? The question is, are we awake?